everyone, welcome to GemChem. Now today's video is on food additives, contaminants and adulterants. So in the first case we are going to deal with the food preservatives. First molecule of food preservative is your benzoate. So in that case we are particularly talking about our sodium benzoate, and this is a class of food preservative which is generally used to preserve your compounds or your food from the contamination caused by bacteria, yeast and molds. This is the structure which is being provided here, and the common application is found in carbonated drinks, pickles, sauces and salads. Now what is the mechanism of action? The benzoic acid actually penetrates the microbial cell walls and disrupts the cell enzyme function, as a result of which the bacteria cannot grow further, thus preventing the spoilage of the food. Now some safety and regulatory aspects of this chemical is being given here. You can read it, but this is not so important. Now the potential health concern is that if it is not taken in the regulated limit, what will happen is there can be allergic reaction, there can be hyperactivity in children, whereas benzoate intolerance can also develop in rare cases. So we can say that benzoate serves as an effective means of food preservation, particularly in acidic products. Our next one is our propionates. So as you can see here, the structure is being provided to you, and we are talking generally about calcium propionate and sodium propionate, mainly used in bakery product so that food gets protected against mold growth. Here it is effective in the pH range close to the neutral. Previously it was acidic in nature, it was preserving the food which was acidic in nature. In this case the pH is neutral. The common application for this one is found in breads, cheeses, tortillas and packaged meats. In the bakery product, propionates are especially valued because it can prevent the mold growth. Now what is the mechanism of action? Now it works in the metabolism of microorganisms, prevents its metabolism and penetrates again through the cell wall to grow and reproduce. Their ability is being destroyed. As a result, you can see that mold growth is stopped. pH range for its action is also provided here. You can see that. Safety regulatory aspects you have to only read, it is not so important. Now the potential health concern given here are gastrointestinal discomfort and behavioral issues in children. Again, just like the previous case, hyperactivity is one of the examples. Now propionates are popular among the food manufacturers because its cost effectiveness. There is widespread use and helps the reduction of the food wastage by growing spoilage. So it preserves environment as well. It do not leave any bitter aftertaste or cause any unwanted reaction in food. Thus we can say that it is a good preservative. Thus overall propionates play a crucial role in maintaining the food quality and safety in modern food production. Now we are coming for the next food preservative, that is sorbate. So potassium sorbate, the structure is provided here to you. This helps again preventing the growth of mold, yeast and certain bacteria in food. It is a salt of sorbic acid. So here if you have OH, that is your sorbic acid. Now replace the H by potassium, you get a salt. Now if we see the common application, they are found in dairy products, baked goods, wines and other beverages. Similarly, mechanism of action is same, where enzymatic functions of different microbes are prevented or inhibited, as a result of which the growth or reproduction capacity of those microorganisms is being reduced. Here also safety and regulatory aspects are being provided. You can just see it and refer to it. Potential health concerns include allergic reactions, mild gastrointestinal discomfort, skin irritation. Now sorbates do not interfere in the sensory properties of food. that is taste, color and texture, so we can easily take it as our preservative. Sorbates considered safe for consumption within a regulated limit. Now again, if you take it more, then it can cause mild allergic reaction or irritation. Our next food preservative is disulphites. In this case, you can see here the compound which is being taken is your sodium metabisulfite. So there is presence of 2 sulfurs and 5 oxygen, S2 and O5 2-. This is also a food preservative. It prevents the oxidation and microbial growth in various kinds of food and beverages. Now the common application for this one is that it is used to preserve dry fruits, wines and cigars, fruit juices, pickles and sauces. Mechanism of action in this case is 2 ways. One is it is acting as antioxidant, another it is acting as antimicrobial agent. When it is acting as antioxidant, the oxidation reaction is being prevented so that your fruit or vegetable which you are considering do not get brown in color. Oxidation occurs when you expose your food to the air. Thus, if you add disulfate, it neutralizes the oxygen molecule and preserves the appearance and taste of the food. When it is acting as an antimicrobial agent, again in this case it inhibits the growth of the microorganisms. As a result, it does not interfere with the food and do not spoil the food. So one of the important aspect of sorbate is that it is exhibiting a dual role. Now potential health concern is that if not taken in the requisite value, if it is taken in excess, it can cause respiratory issue, skin rashes, headaches and digestive discomfort. Environmental and consumer concerns which we consider is that it increases the shelf life of food products, thus reduces the food wastage. Clear labeling of the sulfites in the product helps us to ensure what is the sensitive value to be undertaken for the consumer awareness and safety. So we can say that products concerning these preservatives must be clearly labeled to inform the customers so that unwanted effects are not occurring. Now we are going to discuss artificial sweeteners. First is our aspartame. Chemical composition is that it is dipeptyl methyl ester which is composed of 2 amino acids. One is aspartic acid, another is phenylalanine, and the structure of your aspartame is this one which is given here. In general, you can have a small amount of methanol in it. Now what is its use? It is used in diet, soft drinks, sugar-free gums, low-calorie desserts, sugar-free yogurt and your artificial sweeteners. Safety and controversy, you can just read it. Regulatory approvals also. Now the health concern is important. Earlier studies have indicated that aspartame can be a cause of cancer. It can also break down aspartic and phenylalanine. As a result, these can impact your brain function, so it has a neurological effect. In case of metabolic effect, we can see that it affects the metabolism and appetite regulation. When present methanol is released when aspartame breaks down. As a result, it can cause toxicity. Phenylketonuria. Now, individuals with phenylketonuria cannot metabolize phenylalanine, making even small amounts of aspartame dangerous for them. Now, what is the benefit of aspartame? It has low calorie, dental health, it does not cause any tooth decay, versatility, maintains the sweetness in wide variety of food. So we can say that it remains one of the most studied food additives in history, and however individuals with PKU, that is we have already seen, must avoid it and ongoing research continues to examine what is the long-term impact of aspartame on human body. Next artificial sweetener is your saccharin. So saccharin is one of the earliest sweetener and it is typically found in crystalline form, has no calories, thus it is a popular choice. It is benzoic acid sulfamide. So you can see here the benzoic acid part is present as well as the sulfamide part is also present. Now because of its highly concentrated sweetness, this saccharin is used in small amounts to get desired amount of sweetness. Sweetness profile is 300 to 400 times sweeter than your sucrose. Now sometimes if you use it in higher concentration, it can cause a bitter or metallic aftertaste which can affect the taste of foods and beverages. And when we talk about its application, it can be used in foods and beverages, pharmaceuticals and personal care product like toothpaste, mouthwash, etc. Just read the healthy and safety concern and your regulations. Now in case of advantages, when we are talking about advantages, then it has 0 calorie, do not affect the blood sugar, it has a heat stability, thus it is suitable for your cooking. But limitation is that it has a bitter aftertaste and perception issue. Despite being declared safe by health authorities, we can see that saccharin still carries some historical baggage from the past cancer scars which has affected the consumer perception. Now we need to have a comparison with other sweeteners of saccharin. So if you consider saccharin, it is usually dominant, but aspartame is often preferred for its clean taste, but it loses its sweetness when exposed to heat. Sucralose is sweeter than saccharin, has more neutral taste, making it a popular choice in your general wide range of products. Stevia is also a natural plant-derived sweetener, increasing its popularity by ages, but it lacks any kind of aftertaste. Now saccharin remains an important tool in the arsenal of your artificial sweetener as it is a non-caloric sweetener and ensures you to have a forcible future. Our third artificial sweetener is dulcin. This dulcin has many controversies. Chemically it is para-ethoxyphenylurea and it belongs to the class of benzene ring or phenyl group. This is the structure of it. IUPAC name is 4-ethoxyphenylurea. It is soluble in water but less so in cold water. It can cause liver and kidney damage, neurological issues, carcinogenic potential. Now dulcin was banned due to growing body of evidence regarding its toxicity. Legacy and replacement in general, following the banning of dulcin, other artificial sweeteners were developed. Modern perspective is that dulcin is no longer used in food and is regarded as an hazardous chemical. So this is, you have to always understand that dulcin's case also influenced how sweeteners and other food additives are tested. In conclusion, we can say that it was a hopeful alternative to sugar, but it had lot of health risks. As a result, it could not keep its place in the market. This is the last one of your artificial sweetener, that is sucralose. This is globally recognized for its intense sweetness and low calorie profile. It has 600 times sweeter than sucrose, and when we consider the structure, this is its structure. Now it is created selectively replacing 3-hydroxyl group from sucrose molecule with chlorine atom, and this process is known as chlorination. Sweetness profile, if you consider, 600 times as I have told you than sucrose. Stability, wide range of pH level and temperature, it is stable. Health impact and safety is metabolism and excretion. In that case, unlike sugar, sucralose is not absorbed or metabolized by the body. So after consumption, it passes through the digestive system unchanged and gets excreted in urine. It is calorie free in nature. Just read the safety and regulatory approvals, potential health concerns. It can impact the gut microbiota. So microbiota means your gut bacteria can get affected. Blood sugar and insulin response can get affected. Cooking and chloropropanols. So in this case, concerns have raised that cooking with sucralose at high temperature could lead to formation of potentially harmful compound, which is chloropropanols, which can have preliminary risk to your health. Long-term health effect. So in large quantities if taken, no major health risk, but there is some problems which is not being mentioned. Now uses and applications when we consider soft drinks, carbonated beverages, sugar-free gums, etc. Comparison again given to you, so you can just read it. Finally, we can conclude that it remains a valuable tool for reducing sugar intake and weight management. Last of the sweeteners is sodium cyclamate. This is the composition of sodium cyclamate, and sweetness profile is 30 to 50 times sweeter than your sucralose, and this is the bans and regulations. Regulatory status, carcinogenicity study has been done, so it is a safety concern to you. Current conscious is that consumers are advised to remain within established ADIs for this consumption. Side effects are immense, gastrointestinal issues such as diarrhea. Applications are being provided. Advantages: calorie reduction, stability and cost effectiveness. As dietary preference evolved and demand for low calorie options increased, this remains an important ingredient for formulation of your various foods and beverage products. Now we enter into the last main topic of our discussion, flavors. First flavor which is being discussed is vanillin. It is most recognized and used flavor. We enjoy vanillin ice cream and any kind of vanillin products, right? Fragrance is beautiful. So chemical formula is C8H8O3. This is the structure which is very important for your work. Now there are sources of vanillin. One is natural vanillin, another is synthetic vanillin. Now when we are talking about synthetic vanillin, it is derived from glycol, lignin derived vanillin, and the last category of type of vanillin is your biotechnological vanillin. Flavor profile is it has an aroma and a taste which is rich, sweet and slightly woody. It is used in baked goods, dairy products, confectionery, beverages and savory foods. Now synthetic vanillin versus natural vanillin, you can just read it, not so important. Production of vanillin also, you have to see how it is generated. The three methods for three types of vanillin is being provided here. Health and safety concern, all things have certain health and safety concerns which you need to have known. It can have health benefits as well as it can have allergic reactions. It is antioxidant, anti-inflammatory and antimicrobial properties. The advantages is that it is widely accessible and synthetic production provides a consistent flavor profile in the processed food, and synthetic vanillin lacks the complexity of natural vanillin extracts. These are the challenges. So we can say that it is the cornerstone of your flavoring industry. Next is your alkyl ester. Hope you have done esterification reaction in labs also. So it has a fruity smell, right? So for fruity smell derivation, we use alkyl esters. Chemical structures and chemical composition, it will have a ester bond. It will be volatile, soluble in organic solvents and boiling point is lower, tend to be lower. Types is ethyl acetate, isomyl acetate, methyl butyrate, octyl acetate, ethyl butyrate. Now synthesized by esterification reaction using a alcohol and a carboxylic acid. Another method is that we can create esters using trans-esterification. We have an existing ester, we make it react with an alcohol, then the alkyl groups get exchanged to provide you a new ester. Now uses in the food industry is that it helps in flavoring agent, aroma enhancement, preservative properties, solvents for food additives. Advantage is that natural aroma replication, versatility, cost effective and low calorie impact. Again, you have to read the safety and regulatory aspects for this one. Then we are going to continue for our next part, that is challenges in the use of alkyl ester. So again, volatility, synthetic and natural debate. When we are talking about the alkyl ester, they mimic the natural flavors of different fruit extracts. So it is essential and have immense utility in our flavor industry. Last we have monosodium glutamate. So this is a popular flavor enhancer used in wide range of product, umami taste. Now it is used in cooking over a century. Now when we talk about its compound, it is monosodium L-glutamate and the molecular formula is being provided. History is being given, function and flavor. It enhances the umami flavor, which is one of the 5 basic tastes, along with sweet, salty, sour and bitter. Flavor enhancement is that it does not have much flavor on its own, but it works to intensify the natural flavors of other ingredients present. Natural sources of glutamate are vegetables like tomatoes, mushrooms, seaweeds, cheeses, parmesan, and your protein rich food is meat, fish, etc. Production involves fermentation, and this is your regulation and safety. Generally, this umami taste, this MSG is actually our Ajinomoto, and this is not good for our health. It causes Chinese restaurant syndrome, glutamate sensitivity and neurological concern. Acceptable daily limit or intake in this case is not specific because it is considered safe when consumed in normally dietary amount, but in small quantities we are using it in seasoning, and these are far below any kind of potential risk threshold. Use in food, processed food, restaurant food and condiments. So we can say that it is widely used and effective flavor enhancer. So here ends the topic of food additives and adulterants and contaminants. Hope this was helpful. Thank you for watching. Do not forget to like, share, subscribe and comment. And the password will be provided to you within the description box for this PDF, and the PDF will be made available in the Telegram.